For homework question 11.11, we're asked to arrange the following substances in order of increasing intermolecular forces. And to do that question, we need to understand the intermolecular forces for each of the molecules and what kind of creates each of those intermolecular forces. So why are the intermolecular forces different for each of those molecules? So the first example we have is chloromethane. And if we take a look at that structure and draw it out, we would see I've got carbon, hydrogen, 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 and the chlorine. Chlorine is more electronegative than the carbon, so that's going to be a polar bond. So because of that, I'm going to have dipole-dipole forces. The carbon-hydrogen bonds are nonpolar. Next, I have methanol. Methanol would look like this. And here again, my carbon-hydrogen bonds are nonpolar, but I do have a carbon-oxygen bond that is polar. And more importantly, I have an oxygen connected to a hydrogen. So here I have my strongest intermolecular force would be hydrogen bonding. Next, I've got methane. Methane is just carbon, hydrogen, 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 nonpolar, 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 London dispersion forces. Last but not least is ammonia. And ammonia also has hydrogen bonding because I have hydrogen attached to nitrogen. So the weakest intermolecular forces, right? London dispersion forces. So methane would have the weakest intermolecular forces. Next would be chloromethane, which is A, and the next one's actually kind of difficult because we have two things that have hydrogen bonding, but actually the methanol is going to have stronger intermolecular forces. It's a larger molecule, and the oxygen-hydrogen bond results in stronger hydrogen bonding than the nitrogen-hydrogen bond. So that would put D next, and that would put B with the strongest intermolecular forces. London dispersion forces are nonpolar molecules. Those are going to have the lowest boiling point, so the weakest intermolecular forces. Next would be dipole-dipole, so I need to have a polar bond somewhere. And then after that, I'd have hydrogen bonding if I have a hydrogen attached to an oxygen, nitrogen, or fluorine. And that ties in with question 11.13. Down here it says identify the substances that have the highest boiling point. So they give me dimethyl ether, methane, which is nonpolar, and methylamine. So dimethyl ether is simply carbon, oxygen, carbon, hydrogen attached to those carbons. Right, so I do have a heteroatom with the oxygen present. However, I do not have very strong intermolecular forces for this molecule. Relatively low boiling point. Methane that we diagrammed above is just London dispersion forces, so also very low boiling point. However, the methylamine example, I will have hydrogens attached to the nitrogen, and I'll have hydrogen bonding, the strongest intermolecular force, and because it'll have the strongest intermolecular force, methylamine will have the highest boiling point of this series.